Hi, this is question number 6 from the AQA Core 2 January 2015 exam paper. For the first part of this video, I'd like you to try the question yourself. So if you'd like to pause the video now and try the question. Okay, well done if you managed to have a go at that. The next part of this video, I'm going to give you a hint as to how you can go about answering these questions. So question 6a says solve the equation sine of x plus 0.7 is equal to 0.6 in the interval between negative pi and pi, and giving your answers in radians to two significant figures. Okay, so in order to solve this, you want to undo the sign, and then you want to decide how many solutions you're going to have in this interval here, and then you can solve for x. Okay, part B says it is given that 5 cos squared theta take away cos theta is equal to sine squared theta. By forming and solving a suitable quadratic equation, find the possible values of cos theta. So at the moment you've got a mixture of two trigonometric ratios here. You've got both cos theta and sine theta in this equation. So what you want to do is you want to write this as using just one of the trigonometric ratios, so either cos theta, so just cos theta, or just sine theta. So one of the identities that you could use here is cos squared theta plus sine squared theta is always equal to 1. Okay, for part 2 it says hence show that a possible value of tan theta is 2 root 2. So one of the ways that you can do this is you can actually draw a right angle triangle using what you found for cos theta over here, and then using Pythagoras to work out what the missing side is. Okay, those are my hints, so if you'd now like to pause the video and then I'll go over the answers shortly. Okay, so in this part of the video I'm going to go over the full solutions for this. So for part A, we want to solve this equation here. So we've got the sine of x plus 0.7 is equal to 0.6. So if I take the inverse sine of both sides, that tells me that x plus 0.7 is going to be equal to the inverse sine of 0.6. So I need to make sure that I'm in radian mode here, because we're working in radians, and we're going to do the inverse sine of 0.6. And that gives me 0.6435. 0.6435. Okay, so that's one of my solutions, but because of the symmetry of the sine curve, I'm going to get another solution for x plus 0.7, where I do pi take away 0.6435. Okay, so I want to do pi take away 0.6435, and that gives me 2.4981. Okay, so those are my two solutions for x plus 0.7. I can work out my solutions for x for each of these. X is going to be equal to 0.6435 take away 0.7. .6435 take away 0.7, and that gives me negative 0.057. And I get another solution by doing 2.4981 take away 0.7. and that gives me 1.7981 or 1.8 to two significant figures. Okay, and both of these are going to be in radians. Okay, and then for part B, it is given that 5 cos squared theta take away cos theta is equal to sine squared theta. Okay, so I'm going to use this identity over here, and I'm going to replace sine squared theta with 1 take away cos squared theta. So that's going to become 5 cos squared theta take away cos theta is equal to 1 take away cos squared theta. Now I've expressed this using the same ratio throughout. If I now turn this into a quadratic equation, I'm going to have 5 cos, I'm going to add cos squared theta to both sides, so I'm going to get 6 cos squared theta. Take away cos theta, take away 1 is equal to 0. I now want to factorize this, so I'm going to have 3 cos theta, 2 cos theta, and I think we're going to have take away 1 plus 1. So that gives us 6 cos squared theta, take away 3 cos theta plus 2 cos theta, which gives us the take away cos theta, and then take away 1. So that means that 3 cos theta plus 1 is equal to 0, which means that cos theta is going to be equal to negative 1/3, or 2 cos theta take away 1 is equal to 0, in which case cos theta is equal to 1/2. Okay, so these are the possible values of cos theta, a negative 1/3 or 1/2. So that's the first part of B. Okay, for the second part of B, we need to show that a possible value of tan theta is 2√2. Well, we're going to use this value over here, so cos theta is equal to negative 1/3, and what I'm going to say is that, we'll start by writing that down, is equal to negative 1/3. So cos squared theta is going to be equal to 1/9. So if cos squared theta is equal to 1/9, that tells me that sine squared theta, because cos squared theta plus sine squared theta is always equal to 1, sine squared theta must be equal to 8/9, which in turn tells me that sine theta must be equal to the square root of 8/9. And it's actually plus or minus the square root of 8/9. There's going to be two solutions for this. Okay, and if I simplify that, it's going to be plus or minus the square root of 8 is 2√2, and the square root of 9 is 3. Okay, so we're going to have plus or minus 2√3 for sine theta. Okay, now we've got the identity tan theta is always equal to sine theta divided by cos theta. And so in this particular case, tan theta is going to be equal to sine theta, which is plus or minus 2√2 over 3. So we'll keep it as plus or minus 2√2 over 3 divided by, so sine theta divided by cos theta, which is a negative 1/3. Okay, so that's going to be the same as that's going to be the same as multiplying by negative 3. So let's say that's going to be equal to plus or minus 2√2 over 3 multiplied by negative 3. Now if I multiply plus or minus 2 root 2 over 3 by negative 3, the positive 2 root 2 over 3 will become a negative 2 root 2. So I'm going to get a negative 2 root 2, and the negative 2 root 2 over 3 becomes a positive 2 root 2. So I get negative or positive 2 root 2. So my answer is going to be negative or positive 2 root 2, which shows me that 2 root 2 is a possible solution. Okay, and I just happened to choose this one. I could have gone down this road with the half as well, but I would have got a different solution, but I found the solution that I wanted, which is 2 root 2 already. Okay, I hope that makes sense. Thanks very much for joining me. I'll see you next time.